in the years of our study, when we looked at the trend over 40 years, 30 years, 20 years, 10 years, it didn't slow down. So we saw no evidence of slowdown. If you accept that, then you really have to think about this as a major crisis, as a crisis, I feel, of the magnitude, if I dare say this, of climate change, and intimately related to it because these chemicals are made from petroleum byproducts. So let's not think of these as separate crises. Let's think of these as shared, imminent crises.
Thank you all so much for joining us. Welcome to this month's Omega webinar on the coming population implosion, chemicals, declining fertility, and the polycrisis. My name is Shori Myers, and I'm the director of the Jennifer Altman Foundation, as well as a member of the Omega Advisory Board, and I'm really delighted to be hosting this conversation today. This webinar is co-sponsored by the Omega Funders Network, the Resilience Project, the Millennium Alliance for Humanity, and the Biosphere at Stanford, and the FAN Network. This webinar will be recorded and posted on our website, omega.ngo, so that you can access it later. I am utterly honored to introduce our two speakers today. Shanna Swan is a decorated professor of environmental medicine and public health at Mount Sinai, author of the recently published book Countdown, which describes the long-term trends of declining reproductive health in men and women around the world. Pete Myers, many of you know, is the founder and chief scientist of Environmental Health News. He's the author of Our Stolen Future, as well as a seminal figure in the field of endocrine disruption research and policy, as well as a groundbreaking early thinker on the polycrisis through his founding role in the FAN network. He also happens to be my father, but I promise there was no direct nepotism involved in setting up this webinar. On our call today, Shanna will highlight some of the trends she discusses in the book and explore their ramifications. Pete will take it a step farther to expand into non-animal species and lead us into a discussion, an exploration of how these trends interact with the cascading crises we face. After these presentations, we'll dive into a discussion, and we strongly encourage you to post questions using the chat function in the webinar so that we can get to them during the second half of our webinar today. And so without further ado, I will turn it over to Shanna.
Thank you, Shori. I'm really happy to be here and to talk about the coming implosion, population implosion, as part of your discussions on chemicals, declining fertility, and the polycrisis. And I'm really honored to be, invited to talk to this group of really influential people. So I promise to talk very quickly, so you can ask me to reshow some slides if you want, but I will go through them quickly. So the first thing is I'm going to talk about the problem that the book addresses. And the book was kicked off by a study that I published in 2017 with colleagues. And if you look up in the top left corner, you see a special report in GQ, An Extinct Possibility, the Truth Behind the Shocking Drop in Sperm Counts. So what this was referring to was our paper in 2017, which reported, as you probably all know, that sperm count had dropped dramatically over the prior 40 years from 99 million per milliliter sperm to 47 million sperm per milliliter, something over 1% per year. This was not the first indication of this decline. And in fact, in 1992, a group out of Copenhagen published a very similar paper with similar findings, claiming that there had been a drop in semen quality over the prior 50 years. Not the same time period and not exactly the same data, but it turned out very similar. And I actually was very skeptical about this study and spent 6 months trying to make this result go away by examining possible biases and confounders. Bottom line, I couldn't move it at all, even controlling for everything, including method of sperm counting, selection of men, obesity, smoking, alcohol, everything we could control for did not change this slope at all. So it made me realize that we really might have a problem in declining sperm quality, semen quality, and sperm count. And I spent the next time since then till now really working on this problem. So what we published in 2017 was a meta-analysis, the result of that cumulative work, if you will, over those prior years. And this meta-analysis was the largest analysis of sperm count decline ever done. It was extremely rigorous, systematic, and large, and included originally looking at 7,500 papers in the English language literature, ending up with 185 studies, which were used in this analysis, which shows median sperm concentration by year of sample collection. That's important. The prior study looked at year of publication. We focused on the year of sample collection. But what you see here is that between 1973, our first year of sample collection, to 2011, the sperm count declined from, or concentration declined from 99 to 47, approximately was cut in half in 39 years, which is a decline of about 1% per year, was an overall decline of 52.4%. And count, which is concentration times volume, declines somewhat more, 59%. Now, Countdown came out of this paper and a request that I look at this and expand this, and I did expand it by looking at not only sperm count, but other problems in males, in females, and the intersection of their reproductive systems, resulting in joint problems. Here I'm going to just briefly talk about the males and mention one thing about females, but to let you know that as you go into each of these endpoints, what's striking is that all of them are declining or worsening at about 1% per year. I call this the 1% effect. I think the fact that these are tied together in time is extremely important and points to, although does not prove, similarity of causes. So here you have concentration in Western countries, which is what we've primarily found results on in our meta-analysis. That's on the left. Non-Western countries had too few data to draw any conclusions, but the worldwide birth rates, or number of children per woman, have been declining at about the same rate between 1960 and 2019, decline from 5 children per woman on average to 2.5, cut in half over that time period. And miscarriage rates we have fewer data on, but they're increasing at a comparable rate, as is testosterone lowering, fertility, testicular cancer increasing, male genital birth defects increasing, and so on and so forth. So what could be causing this? Well, I like to break out causes into broad categories, and today I'm not going to spend much time talking on lifestyle factors, although I have looked at a number of these. My work has been focusing, as I think you know, on chemical exposures, and particularly the endocrine disrupting chemicals, and most particularly on those chemicals that can affect steroid hormones, and that is primarily my work has been on phthalates and to some extent on the bisphenols and the pesticides. So turning to reproduction and the development of the genitals, where I've done a lot of work, I want to show you the schematic, which just shows that the differentiation of the undifferentiated sex organs early in pregnancy are dependent on the presence of testosterone, actually at a critical time, to develop in the male to the male typical, that is an XY individual, will develop the male typical organs under the presence of testosterone. Without the presence of testosterone or inadequate testosterone, that masculinization will be arrested or not present at all, in which case you have the female development. So what can interfere with testosterone levels? Well, phthalates is one category of chemicals that can do this, which are present, as we know, in personal care products, in soft plastic, in plastic tubing, and entering in our body in all these myriad of ways. And what happens when an animal is exposed to testosterone at the critical period in gestation, the peak that's present in the unexposed animal during that period, that peak in testosterone is erased, is completely wiped out by diethyl hexylphthalate administered to the mom in the critical period. So what you see here is that testosterone is actually really necessary for this animal developing to have the proper amount of testosterone to make that transition to the male typical genitals. And in fact, when the mom is exposed to DEHP, not only are these genitals smaller, and which is less masculine, we also see male genital birth defects. And in particular, one thing that I've studied quite a bit is a shortening of the perineal area called the anogenital distance. So I asked, what about humans? At that time, when I started to look at this, I learned that the entire US population was exposed to phthalates, including pregnant women. And I wondered, would we see in humans the same phthalate syndrome that had been identified in the rodent? And so to do that, I had some stored urine from a study that included pregnant women who gave urine, got those samples measured for phthalate metabolites, and then I brought the babies in and examined their genitals. And I used an exam which was modeled after the animal study. I made a translation of the animal study to humans. And what we found in repeated studies was that we did find a phthalate syndrome in human males. We published this first in 2005. It actually had an impact on legislation. I think it played a role in the Consumer Protection Act of 2008. It also influenced consumers to lower their exposures or to ask for reduced exposures to diethyl hexylphthalate, the most potent anti-androgen. It also showed that phthalates are human endocrine disruptors, and it showed that AGD is a marker of the fetal androgen exposure, which is hidden, of course. We can't actually know that directly. I replicated that study in 2015 and did it better, more carefully, and found comparable results. So that whole arc, if you will, from showing phthalates to be anti-androgenic, showing them in animals to cause the phthalate syndrome, finding that in humans in 2 studies, I believe leads us to a conclusion that phthalates do cause the phthalate syndrome in humans. Well, what does this mean? Why do we care? What does this have to do with health? These boys don't look odd. They're not weirdly malformed usually. And so what we really wonder is this affecting fertility and sperm quality and number? And to look at that, I have to ask you to jump 20 years because these babies were just born. They don't have sperm or fertility function until they're past adolescence and into adulthood. And so we had to use the animal result that, quote, AGD is forever, that AGD is a permanent marker that an animal is born with. And if he's short at birth, he's going to be short throughout his life. If you assume that, and that is a bit of a leap of faith that we need to pin down, I think, then you can ask in a young man, for example, is his sperm count related to his anogenital distance? And we did that study, and the answer is yes. So you see here that a longer anogenital distance is directly related to a higher sperm count. And in other studies, this was replicated and also shown that men who are infertile also have a shorter AGD, as do children with genital birth defects. So I think we have demonstrated that prenatal exposure to these anti-androgenic phthalates do lower sperm count. But the critical timing is harder to pin down. In animals, we know there is a very small window during which this effect occurs. It's actually a 3-day window called the male programming window. In humans, it's more difficult, of course, because we cannot administer the phthalates and our subjects are continually exposed. However, by getting 3 samples in 3 trimesters, we were able to show that the association between some of the DHP metabolites and anogenital distance was restricted to the first trimester. I also want to say that timing is important for another reason, namely that an exposure during pregnancy or immediately prior to pregnancy on the part of the father causes a permanent change. In here, with respect to smoking, a 40% reduction in the man's sperm count. But if the man himself smokes as an adult, he has less of a reduction, and that is reversible. So another important part of timing is that the timing of the exposure determines how permanent the change and how great the change is. So what are some consequences of this problem? First of all, it's perhaps surprising to you, was to me, that men with low sperm count die younger. Men who are infertile actually die younger. And a critical point here is the number 40 million per milliliter for sperm count. Below 40 million per milliliter, it becomes harder and harder to conceive a pregnancy. And by the way, that is likely where we are right now. If you think about the decline down to 47 in 2011, we're now at 2021. 10 years later, we might be at 37, but I think it's likely that we are already have a median, which is below 40. And that means that men in this range of sperm concentration are losing years of life, whether or not they have born a child. Another important consequence is that the exposure is not just to the mother and not just to the fetus she's carrying, but to at least one subsequent and probably more generations. So what are some solutions? These are all things that people on this call are pretty familiar with, I think, but I'll just go through this, that we have to remove hormonally active chemicals. I don't see any way around it if we're going to reverse the changes that we've seen. As Pat Hunt has shown in an elegant study in Washington, that when you remove these exposures, you can reverse these damages in 3 generations. That's good news for the mouse she's studying with a length of life of 2 years, intergenerational gap of 2 years. It's harder lesson for humans because that would be the equivalent of 75 years. And we really can't wait that long with sperm counts as low as they are. So we also have to remove chemicals that cause harm at low doses, because we know these are largely low dose effects. We have to remove environmentally persistent chemicals and the myriad of chemicals that have not yet been tested at all for toxicity, and replace those obviously with the converse, those without endocrine disrupting effects that are free of low dose adverse effects and are minimally persistent, and I think perhaps most importantly, shown to be safe prior to marketing. So to do that, we have to regulate in human relevant scenarios. Low dose effects, that's what we're exposed to. We're exposed to mixtures. We have to worry about environmental persistence and of course the risks to our untested chemicals. So I just briefly summarized this book. I hope you look at it. I hope you like it. And I'm ready to hand this off to Pete. Thanks. Bye.
Excellent. So you'll recognize this slide from Shanna's presentation. And I want to start here and dive into a detail that Shanna briefly mentioned. Here it is. This is the 50% decline over over 5 decades that Shanna mentioned in median sperm count. Looking at it a little bit more closely, these are projected curves into the future. These two imagine, hey, we've managed to do something to get ahead of this and we're beginning to reverse what was happening. This simply represents business as usual. Always something dangerous to do in science, as we've learned from climate work, but it projects that the curve will intersect a 0 sperm count for the median, a median sperm count of 0 in 2045. That's not very far off. In fact, it's 24 years from now. It's close. It's within a generation. Today's toddlers, these boys, are going to be part of that cohort. Half of them will have 0 or less. Half of them will have greater than 0. And many of those with greater than 0 will still be subfertile. It's not a good situation, and it has many social implications, as we'll talk about later. I'm sure there will be questions about it, some of which we can answer, some of which we can't. But I want to step back a little bit, because this story is not just about human declines in fertility. We've turned the tables. Humans used to use birds, canaries, to tell them when it was getting dangerous in a coal mine. Now we are the canaries in the human-created chemosphere, in which everything is getting exposed, not just people. But we haven't had the millions of dollars available to us to do the research, the millions of dollars it took for Shanna to do that research, to nail that down with just about any other species on the planet. There are reasons why we think it's plausible that other species are being affected. There's some data which show that they are, but to a significant degree, we're flying blind. EDCs, endocrine disrupting compounds, are now ubiquitous in the environment. They're on the highest mountains. They're in the Arctic snow. They're in the Antarctic deep. They're at the bottom of the Marianas Trench. They're in remote tropical rivers. They're in sandy beaches worldwide at serious levels. They are everywhere. It's kind of astounding that this is a reality of life today. How did they get everywhere? Well, we carry them. We put them in landfills and they leach out of them in landfill leachate, and they get into rivers and go into the oceans. In warm areas, they volatilize. The wind blows, it carries them into the most remote forests on the planet. Rivers and ocean currents carry them. Animals carry them when they migrate. The bottom line is there is no uncontaminated place on Earth. None. Let me give you a very brief example of what this looks like. Now here's a map, a diagram imagining the winds coming off the Caribbean Sea, going into banana plantations in Costa Rica, and then going past those plantations uphill into cloud forest. Banana plantations are heavily treated with pesticides, including endocrine disrupting compounds, and they volatilize from those plantations. Because they're semi-volatile, they're carried by the winds downwind and up the mountains. And as the wind rises up the mountains, something called adiabatic cooling goes on, and they are deposited on the forests. And the forests in the cloud forests of Costa Rica have higher levels of pesticides on them than the forests adjacent to the Caribbean lowland banana plantations. That's happening all over the world. I was struck by this when a study came out a few months ago claiming that butterflies in the Sierra Nevada were being hurt by climate change, and it couldn't possibly be contamination because the highland forests were pristine. But those highland forests are downwind of a massive application area of pesticides, and the same adiabatic cooling takes place going up the Sierra. We're fooling ourselves if we think we're working in pristine habitats. So a little bit about hormone disruption. Hormones are chemical signals for cells that receive them to do really vital things that affect all of life. How many fingers we have, whether our brain works properly, whether we can deal with glucose in the bloodstream and avoid diabetes, whether we're fertile. If there's no receptor for the hormone in a cell, there's no impact. Of the hormone or of an endocrine disrupting compound. Normally what happens is the hormone binds with a receptor either on the surface of the cell membrane or within the nucleus of the cell and provokes a response. And those responses can be many different types of responses, but that's the fundamental action of hormones. And when hormone disrupting compounds are in there, they interfere with that process. They can either mimic the hormones and send a signal when it shouldn't have been there and cause things to happen that shouldn't be happening, or they can block the signal and prevent important signals from reaching crucial cells and tissues. So a couple of key points in the science of endocrine disruption. Severe effects take place at very low concentrations. That's especially true during fetal life. For a hit that might happen in adulthood, it could have very little effect. The same hit to a fetus, same concentration, can destroy fertility for the lifetime of the individual exposed. EDCs hack hormone signaling. They're taking advantage of evolution that has built a system of communication that is acutely sensitive to very specific molecules. And unfortunately, over the last 100 years, we have filled the environment with molecules which coincidentally mimic and substitute themselves, hack hormone signaling, causing adverse effects. What are low doses? Well, hormones are working in the low parts per trillion to the high parts per billion. Traditional toxic agents cause damage in the low parts per million and higher. EDCs overlap heavily with the zones of hormone action at low parts per trillion and parts per billion. So they're acutely, they are extremely powerful at causing low dose effects. And just to put it in perspective, what's a part per billion? Just think of it, imagine a molecule of serum that's got one part per billion of bisphenol A, one of the classic endocrine disrupting compounds in it. How many molecules of bisphenol A do you think are in that one drop of serum? How many of you remember Avogadro's number from basic chemistry? There are actually 2.65 trillion molecules of BPA in that one drop. Excuse the French, that's a shitload of molecules to be around in a drop of serum, especially when you view that in the context of famous work that won a Nobel Prize in 1971 by Sutherland, which showed that a single receptor hormone receptor interaction at the surface of the cell membrane is amplified through a series of cellular processes that can lead to hundreds of thousands, if not millions, of cellular events as a result of that one hormone receptor binding. There's a huge amplification that is all part of the specialization of hormone signaling that's been created by evolution. So what about other parts of the biosphere? Unfortunately, as I said, we haven't had the millions of dollars it's taken Shanna to establish what's happening to men's sperm count. Most of us, though, are familiar with this. You used to drive in the springtime along a river or in a marsh, and your windshield would be covered with insect splat. And that is much less common to happen now. I think we've all experienced that. Let me use one example of an insect where we have at least a little bit of data. Ants. Ants turned out to be atmospheric traps for the very same contaminants that Shanna has implicated in male sperm count decline. Ant cuticles trap those phthalates from the atmosphere as they've been semi-volatilized and spread throughout actually the planet. And what some French scientists reported recently was that if you look at the levels of phthalates that are in ants, they rise to the level that experiments show interfere with fertility and immune system function in the ants with the higher levels of phthalates. And they did this work in 3 different continents. Every single sample of ants measured had phthalates in it, some higher, some lower. They also looked at, one of their study sites was in the Amazonian rainforest in Guyana, down here at the Noragores field station. And they found phthalates not just in the populated areas of French Guiana, but also in the middle of the Amazon rainforest. They are everywhere. So here we are the canaries in this coal mine. We need to be looking for effects on animals. We're seeing them in some places where they've been well studied. A report just came out looking at reproduction in marine species, saying that chemicals are interfering with fertility in a wide array of marine species. Every place we have a chance to look, we are seeing the effects. Every place. And I don't think that bodes well for what we're going to be seeing in the future. It definitely does not mean this is just an effect on human fertility. It's affecting a lot more of biodiversity on the planet. And I would add one other thing, and perhaps use this as a segue into the question and answer period, and also talk about the polycrisis. To my knowledge, with respect to human health trends, there may be only one other trend that is of the same magnitude of change over the same time period as human sperm count decline, and that's the increase in the rate of autism. If autism rates increase as they are increasing today, and they have exponentially for the last several decades, 1 in 2 boys in the United States will be autistic by birth year 2050. And I want you to ask, how could we possibly deal with climate change if we have a population, a society that has such a high percentage of kids who have neural problems like autism? I'll stop there. Thank you.
Great. Thank you both so much for that incredibly depressing set of numbers and statistics. Pete, if you want to stop your screen share so that we can see you, we'll move now into the question and answer session. And one note I would just bring up is that I believe Greta Thunberg is a person with Asperger's or autism spectrum disorder. And so if we get more Gretas in the world, I would not complain about that. However, there's no guarantee, obviously, that.
And Greta is a functional.
Greta is
a very functional person.
Beyond functional, visionary, I would believe. So I'm going to turn to some questions now. Thank you all so much for plugging those questions in the chat. Pete, I want to take your observation on insect species and just ask the question of, if we're seeing these implications in ants, what are the implications for pollinators and other foundational species that are not just critical for ecosystems, but also the biological systems on which we depend?
That's easy, the same. We are seeing massive declines in pollinators, particularly the wild bees. And we don't have a really solid evidence as to why that's happening. There are many factors that are being identified as potential causes. But if I had to bet, the widespread distribution of endocrine disrupting compounds and other types of biologically harmful chemicals, although EDCs are most important because of the extremely low doses at which they work. I think though you cannot ignore those as potential causes.
Thanks. I'm going to move to Peter Goldmark's question here, which I hope was a little tongue-in-cheek. It reminds me a little bit too much of Margaret Atwood's work. But he asks, as a bridge partial solution, are groups beginning to talk about the wider use of proxy impregnators who have high sperm count? Obviously, Shanna, your description was of the male impacts on sperm count, but your book goes into many more issues, not just male sperm count, but also other impacts on men, as well as impacts on female reproductive systems. And that begs the question of what sort of reproductive technology, what sort of assistance is going to be necessary over the coming decades. And can you speak a little to the disparities in access that we're going to find, both disparities in exposure to these compounds and those impacts, as well as disparities in access? And so what are the consequences for justice?
Right. So let me just say, as far as Margaret Atwood and the pollinators, there has been a rise in surrogacy at about the same rate as other problems have been going up. So surrogacy is on the rise. Use of stored gametes is on the rise, and assisted reproduction. So I don't think it's completely tongue in cheek to ask about the what's going to happen and what kind of technologies will people be able to use in the future. I believe that they will get better and better because we're very good at, as a species, developing new useful technologies when we need them. But not everybody has access to them, as you pointed out, Shori. And so let me just say a few things about the equity of these questions. First of all, disadvantaged communities are more highly exposed. That's been shown many, many times. Okay, so they get bigger hits. Secondly, the same hit in a poorer, if you will, sicker, lower health status community is going to be greater for the same. If a given hit of an EDC is going to affect, or is likely to affect, and we've shown it for BPA, by the way, in our study that's coming out now, affects the risk of autistic-like behaviors much more in the single study center that we have that's poor and Black than in our white upper middle class centers. So there's it's plausible, and there's more and more evidence coming out that the impacts are greater in disadvantaged communities. Third, the ability to access things that will diminish exposure, such as unprocessed food, organic food, and the ability to get assisted reproduction, of course, is more limited in people of lower incomes. So I think for all of those reasons, this is a very inequitable situation, and we have to address that part of it.
If I could add a couple of thoughts to that, the inequities are huge. We're moving toward a circumstance when rich people will be able to use ART and others won't.
Right.
But Margaret Atwood, to return to her, wrote a very prophetic, I thought, essay in 2017. And I hope this doesn't offend anybody, but the title of the essay was, "It's not just climate change, it's everything change." And it's the interactions between everything and everything else that are going to be the big drivers of the societal issues that we face in the future.
Thanks. I'll turn to Linnea's and Robert's questions now. Linnea, you ask about autism, associating autism with phthalates and other EDCs. Yes, there is a lot of data out there. I can circle back and share some of that with you. And I know Pete has some as well. Yeah, Pete.
If I could add to that, a colleague of mine, Emily Rissman, who was at University of Virginia and is now at the University of North Carolina, has studied BPA-like attributes in mice exposed in utero to bisphenol A, and finds not just effects on the first generation of offspring, the sons and daughters, but that without additional BPA exposure, those effects are carried on for up to 4 generations beyond the first exposure. It's called transgenerational epigenetic inheritance. It's one of the best studies of that phenomenon. But there are many studies that connect a variety of neuronal challenges to exposure in the womb to endocrine disrupting compounds. Shanna herself has done some of that work. And I mentioned the autism because the time rate of autistic increase is so dramatic and so troubling. And yes, we don't know what percentage is likely to be caused by endocrine disrupting compounds, but it's pretty clear that some percentage is. And it's also pretty clear that if we act upon it, we can decrease those exposures and hopefully decrease the burden.
Great. I'll turn to Robert's question now, and then we'll get into some discussion of, okay, we have a problem, what can we do about it? But first, Robert's question, can environmental plastics be directly connected with human toxicity? And I would expand that to marine toxicity as well, because I know you've been thinking about that, Pete.
The answer is yes. And I have quite a few webinars and TED-style talks exploring that very issue. Plastics, many plastics, not all plastics, but many plastics are toxic. Some of them are toxic because of the basic monomer that's used to build them, like BPA. BPA leaches out of polycarbonate plastic, and it interferes with a whole series of endocrine effects. Phthalates are additives to plastics. So if you're using phthalates in the neonatal intensive care unit to deliver blood or liquid or food to a baby, they're getting infused with phthalates. I'm afraid that's the medical truth. Yes, and I could go on at length about that. Plastics are a major source of endocrine disrupting exposures.
If I could just add, the question was partly that, it was also the human toxicity part. And I think that what my studies, I call them I call what I do human toxicology. And I think that's because it's informed by the animal toxicology. But I think what I have shown is a link between environmental plastics and human health by showing that the mother's exposure to phthalates during pregnancy, particularly first trimester, causes changes in the male genitals, which are associated with definitely an adverse effect, which is lower sperm count.
Thanks. I'll turn to Jenny Russell's question now. What has been the response from chemical producers and companies? Any admissions or changes in practice, or do we need to assume a regulatory solution? Pete, I imagine you have a few things to.
Well, the first is good news. None of my colleagues in endocrine disruption have died, except for Lou Gillette, and that was the natural causes. But the pushback from companies has been fierce. And perhaps the best example of that is what happened to Tyrone Hayes, who just last week was elected to the American Academy of Arts and Sciences. He's a professor at UC Berkeley. He's worked on an endocrine disrupting compound called atrazine, which is used as an herbicide, one of the second most widely used herbicide in the world. And Syngenta came after him fiercely as his data began to emerge. Some of you know that I was the director of the W. Alton Jones Foundation for a number of years. When Syngenta forbade him from publishing his results because they paid for them, Jones Foundation gave him the money to replicate the studies, and he then published them again. It reached the point where he would be testifying in various hearings around the state, particularly in agricultural states. Once this story in Illinois, he was testifying before the Illinois Senate. And there were representatives of Syngenta at each of these episodes. And at this particular one, a guy came up to him who Tyrone knew to be following him from Syngenta. And he whispers to Tyrone, he says, "Hey, Tyrone, you travel a lot. Don't you worry about your family?" So it's been, there are other people have stories not quite as severe as that, but it's been quite common.
I'd like to just add another response of industry, which is what we call regrettable substitution. And those in the field are very familiar with that. But let me say from my own personal experience, I was very pleased when I saw that in the 10 years between the recruitment of our population for our first study in 2000 and our second study in 2010, the level of diethylhexylphthalate, which we had fingered in our first study, had dropped 50%. 50%. I was stunned, actually. And what caused that was probably a combination of concerns by consumers, pressure by consumers, manufacturers wanting to put out a more acceptable product or perhaps a safer product. But I later learned that they had introduced DINP and DIOP alternative phthalates to take their place. And these were then shown in another $5 million study to be equally harmful. And this is the same thing that happened with bisphenol A being replaced by bisphenol F and bisphenol S, and consumers buying bottles labeled BPA free, thinking they are getting rid of the problem when it should be saying bisphenol free. Of course, none of them do. So I think that this way of I don't know how to call it, fighting back by the industry against the science is really deeply unfair to consumers who I think should be outraged.
Part of the solution to this is acknowledging that the substitutes that we have available to us today were first synthesized using the same flawed principles to guide synthesis that led to the bad stuff in the first place. And they've never been tested adequately. What we have to do is enter into a new generation where we are testing new materials being synthesized anew by chemists specialized in doing that, but helping them understand which of the chemicals they are working to take to market are endocrine disrupting chemicals and which aren't. We now know enough science, we can do that. We've actually published on how to do that. It's definitely within reach. And actually we did that work to show chemists how they could make money by producing safer materials.
Great. Thank you. I want to turn now towards the question of solutions and how we manage this problem. What would you point to as regulatory mechanisms that we can start building off of, opportunities for funding policy that are particularly exciting? Where would you look to find those necessary safeguards that we'll be needing?
You want to lead, Shanna, or do you want me to?
I think you lead and then I'll go next.
Okay. The first thing that we need to do is we need to design, working with chemists, a new generation that's inherently safer. And we can do that, as I just mentioned. The second thing we need to do, we know enough science now to understand how deeply flawed the approaches taken by the FDA and the EPA and their counterparts in other countries are at detecting what's safe and what's not. The BPA safe level, if they were to accept their own data and use modern endocrinological principles, their safe level of BPA would have to be reduced from the current estimate of safe by a factor of 20,000. That's how wrong they are today. But we know the science, we know how to correct that. And then the third thing we need to do is we need to take advantage of the growing, burgeoning, exponentially expanding interest in consumers in having safer materials and help them understand how to gauge what's safe and what's not. Because right now, the agencies are failing utterly at doing that.
So what I would say, one really critical point is that we know what's in people's bodies. We know how much X, Y, and Z is in there, but we really don't know explicitly where it comes from. So there are big statements about most phthalate exposure is from food. I believe that's probably true. But where? Where from the food? Is it from the packaging? Is it from the processing? Is it from the cooking? Is it, and I think getting down to specifics now, we can't, if we don't find the entry points for these chemicals into our lives, we can't keep them out. And so I think it's great that we know that what's in the general population. Now we have to find out exactly how to get in there.
Good. And I would note that not everywhere around the world is in the same regulatory spot as the United States. Pete, would you mind saying a few words about what's going on in Europe right now?
Well, on October 14th, the Executive Vice President of the European Commission, Frans Timmermans, issued a public statement, an announcement that the European Commission is embarking on what they call the chemical strategy for sustainability. It's a massive change potentially in European chemical policy. And a whole bunch of people on both sides of the pond have been working to make that happen. Among them, the Endocrine Society, the world's biggest professional association of endocrinologists, in other words, the people you want to go see if you've got an endocrine-related problem, they have been lobbying in Brussels here's this guy who's not my hero, but who, and comes from a different part of the political spectrum, but who, as he was listening to Shanna's explanation of her work, he got it so thoroughly. It was really impressive. So Spotify, Joe Rogan, Shanna Swan, listen.
Thank you, Pete. Yeah, hopefully these things are making an impact. And as Jeremy Grantham said, who's, by the way, whose foundation produced that graph that you saw that I showed you and Pete showed you, and because he likes to push the envelope, and he said we have to outrage. We have to use propaganda. We have to bring about outrage because we have to, you know, make people aware of this problem. But specifically, how to keep things out. Again, lots of resources in Countdown. But I would say that there are also lots of groups that are very good at suggesting specific chemical choices. If you want to make safer, buy safer personal care products or laundry products or cleaning products, et cetera, et cetera, et cetera, you can go, for example, to Environmental Working Group, and there maybe you want to suggest any other story, but there are fortunately resources for people. But here's the problem. If you don't think there's a problem, you're not going to go there. So I think the first problem is recognizing the problem and making people aware that this is a problem. Who's heard of this? How many people have heard about endocrine disruption? If you go into a meeting and ask people, unless they're part of the society, you might get a few hands, that's about it. It's not on the radar yet. We have to put it on the radar, and that's the first step in getting it out of our bodies.
And indeed, I would say, you know, in addition, there are folks who can afford to buy their way out of this problem, and there are folks who can't afford to buy their way out of this problem. And it is even more important that we protect those who can't. For those who do want to learn a little bit more about their own health, I would point to Leah Segedie's book, Green Enough, which is quite a good resource. And then a website called Because Health that's run by the Collaborative on Health and Environment that has some really excellent personal choices about what to do. And I want to turn again to Peter's question. How do we know how long EDCs last in the body? How long is this going to take us to get rid of? Are there some that, you know, decompose right away? Are there some that stick around longer? How do we go about cleaning up our bodies and our ecosystem?
So
That's go ahead.
Go ahead, Pete. Go ahead. Okay,
that's a great question.
Yeah, yeah.
And it depends upon the chemical.
Mm-hmm.
The infamous forever chemicals, the perfluorinated compounds, are endocrine disrupting compounds. They often get more press because they're around forever. They don't decline in your body in time that's relevant. Others, like BPA, disappear certainly within 48 hours. The problem with BPA is that it's everywhere in the environment, so you're always exposed. So with something like BPA or phthalates, which is like BPA, it gets out of your body fast, but it's everywhere, so you're always exposed. The challenge there is to eliminate the sources of exposure. With perfluorinated, we don't have the answers yet.
Yeah.
Shanna, would you add anything to that?
I was pretty much just gonna say that, you know, they're quick in, quick out, but constant. That's kind of the way we think about exposures. You're getting them in all the time because they come in through your foods, through everything in your home, through the dust, through the air, through your skin, personal care products, through smell, anything that's has fragrance, has chemicals in it of concern. So you have to really make a concerted effort. You can do that. There's a book called Slow Death by Rubber Duck, in which Rick Smith actually did an experiment to lower his exposures by making a little laboratory in his house in which he kept everything very, very clean, and showed his levels went down, and then when he brought things back that he was used to using, they went up again.
But he was not able to manipulate perfluorinated levels. Phthalates and bisphenol A, they went down, went up, but not the perfluorinated compounds. It's a brilliant, funny book, and there's a 10th anniversary issue of it that just came out last year.
Great. So we're almost at the top of the hour. I'd like to ask for just a few closing thoughts from Pete and Shanna. And before I open that up, I'll post my email in the chat for anyone who would like to ask follow-up questions, get more resources, get more connected to the studies. I'm happy to be a resource. And Pete and Shanna, if you want to share your email addresses in the chat as well,
Sure.
that would be great. So closing thoughts, should we go Shanna first and then Pete?
Whatever Shanna wants.
Sure. So I hope that we've convinced you that there's a problem. I believe that it's a very critical problem. I don't think that we can hit that 0 point. By the way, there aren't negative sperm, so we have to sperm count. So we're going to come closer and closer to that 0 line unless we change things. Somebody asked in the chat, how do we know that things are continuing to get worse? I don't know about the last 10 years, but I can tell you in the years of our study, when we looked at the trend over 40 years, 30 years, 20 years, 10 years, it didn't slow down. So we saw no evidence of slowdown. If you accept that, then you really have to think about this as a major crisis, as a crisis, I feel, of the magnitude, if I dare say this, of climate change and intimately related to it because these chemicals are made from petroleum byproducts. So let's not think of these as separate crises. Let's think of these as shared imminent crises.
Thank you, Shanna.
I think that was excellent, Shanna. Let me add one note that Jeremy Grantham would have added had he been part of this panel. Jeremy, as many of you know, is a famous investor in the Boston area, billionaire investor, who over the last several years has been lecturing to impact investors about sperm count declines and related issues. And the reason why he is so fascinated, fixated on this issue is he's looking at the economic implications of inverting the population pyramid. We need lots of young people compared to old people for our current economic models to work. If we invert that pyramid, we aren't going to have the capital we need to deal with climate change. It's that simple. Exactly when the inversion becomes dramatic enough to have a hit, I don't know. But I know that's why Grantham is so upset about this. He actually wrote an op-ed in the Financial Times in March about Shanna's book. And interestingly enough, the editor of Financial Times is a friend of his, of Jeremy's, told Jeremy it was the second most read article in the week on the weekend that weekend.
Well, thank you for that extremely appropriate Omega cross-cutting issue, sectoral, you know. Everything's coming together. I think we could talk about this for another hour. Hopefully we will return to the subject of conversation. With that, I'll just thank Shanna and thank you, Pete. Really appreciate your time and your energy and your dedication to this work. So looking forward to our next conversation. Thank you all for coming. This recording will be posted on the website and we look forward to seeing you next time.
Thank you, Sharon, and everyone who participated.
Yeah, thanks very much.